So now we're going to look at how to do initial rates method problems. So you're going to be given data from multiple experiments. And what you're going to see is that the experiments will be in order of just when they were done, but you're going to be given data, in this case, the initial concentration of hydrogen peroxide in molarity, the initial concentration of iodide in molarity, and the initial concentration of hydrogen ion in molarity, and the initial rate of that particular experiment. So this is the reaction. We don't need to worry about the stoichiometry. We're just looking at what's happening to our concentrations in these 4 separate experiments. You're asked to determine a rate law. And so what I typically do is I look at the experiments and see how can I get some of the experiments to cancel out. So in this case, on purpose, I chose rate 2 over rate 1. And that's because if you notice that my iodide concentration is identical, and so that cancels out. My hydrogen ion concentration is identical, and that cancels out. And so also my rate constants cancel out. And what happens is I end up only having the concentrations of the peroxide, and I just arbitrarily call them to the exponent m. You can use any exponent you want, use letters. So when I calculate this, I get 2 to the m equals 2. And so mathematically, the m has to equal 1. So what that tells you is the exponent in regards to the peroxide. So it's the same idea for the next calculation. I chose on purpose rate 3 over rate 1 because I saw that my peroxides were going to cancel out. My hydrogen ions are going to cancel out. That gave me the iodides. I ended up getting 2 to the n equals 2. So n mathematically equals 1. So what this tells you is it's first order for the iodide. It's also first order for the peroxide. That's just a coincidence. And then I did the same idea with my rate 4 over my rate 1. And in this case, my peroxides canceled out, my iodides canceled out, and I ended up calculating my hydrogen ion. So I end up getting 2p equals 1. So p has to be 0. That means it's 0 order in regards to the hydrogen ion. Okay, so if we look down and see what we now have the rate law. We know the rate law is 0 order for the hydrogen ion. So what you can do when you have the 0 order is you don't have to show it. You can just leave it out. So then we don't have it here. We've got first order in peroxide. If you don't put an exponent, it means first, 1. It's first order in the iodide. So you can write the rate law this way, or you can leave the 1. That would be fine. So in order to find the rate constant, all we do is choose one of the experiments, put the corresponding data in. So what we mean is you use the rate for that experiment, the concentrations for the particular reagents, and then you can solve for K. Okay, so let's look at another example. This is just more practice. Well, I guess I need more practice in doing this, don't I? Okay. So the best way to do well in this course is just do as many examples as you can so that it's second nature and you don't even have to think about it. This is the same exact idea. Be cognizant of what rates you're going to choose. I'm going to choose 2 over 1 because if you notice, cancel, cancel, I just have to solve for this. I get 2 equals 2 to the power of m. My m equals 1. For the next one, I chose rate 3 over rate 2. And that's because this is going to cancel. This is going to cancel. I get 2 equals 2 to the n. My n equals 1. Again, this is just a coincidence, but quite often you get first order. And then I'll choose rate 4 over 1. This is going to cancel. This is going to cancel. I'll get 4 equals 2 to the power of p. My p is 2, so it's second order. And that gives us our rate law. Okay, so we're also going to show the units for the K. A lot of times in problems, the units for the K are not shown, but you still have to be able to do them because it's fair game to ask you what the units are for the K. So what we're going to do is we are going to put in our units. So this is our rate law. So I chose a particular experiment, put the rate in for the experiment. K is unknown. K should be lowercase. I put in the corresponding molarities and I put in my exponents. Then I solved for K. Now I solved for K. There's my number for K. Now the units for rate should be molarity over seconds. So molarity over seconds has got to equal the units on this side. So all of these units, the units of K and all of these molarities have to equal to molarity over second. So how would we get molarity over second? We need 3 of these molarities to cancel. That's why molarity would be on the bottom. We need to have a per second in our K to get the rate for a per second. So that's why we put in the per second as our unit. Okay, we're going to look at this next time.